Chapter 2 is titled Functions and Their Graphs. In this chapter, we'll look at a variety of parent functions, we'll write equations, we'll solve real-world situations, and we'll look at transformations. Lesson 2.1 is all about linear functions. We'll look at linear equations in two variables. Topics will include finding slope of a line, writing and graphing an equation, looking at parallel and perpendicular lines, and then modeling real-life problems. Slope of a line. The definition for slope is the number of units a line rises or falls vertically for each unit of horizontal change from left to right. You have a couple of examples. If your line rises from left to right, that means it looks kind of like you're walking up a hill. If your graph falls from left to right, you'd have a slope that's negative, and it looks like you're going downhill. Another way to describe slope of a line is rise over run. And then the formula you would use requires two coordinates on that line. If you identify two coordinates as x1, y1 and x2, y2, then the formula would be the difference in the y values, y2 minus y1, divided by the difference in those x values. Whoops, that should be a 1. There we go. And make sure to always simplify that fraction. All right, let's try a couple. Find the slope of the line passing through each pair of points. For that first set of ordered pairs, I identified each pair with a coordinate system. x1, y1 for the first ordered pair, and x2, y2 for the second. Applying that definition of y2 minus y1, we would have our slope equals 1 minus 0 in the numerator over 3 minus negative 2 in the denominator. To simplify that, the denominator has that double negative, which means we'll change that to positive. 1 minus 0 on top is 1. 3 plus 2 on 5 is 5 on the bottom. The slope would be positive 1/5. We would say this line rises from left to right. All right, you guys try the second one. Find the slope of the line, and then we'll describe what it's doing on our coordinate system. For this slope, you should get 0 over 3 when you find the formula, or when you use the formula. But 0 divided by 3 can be simplified. That actually equals 0. So that isn't a positive or a negative answer. It's just 0. If your slope ever is 0, it doesn't rise or fall. This is an example of a horizontal line. And we would say there is no slope. Okay, try the next one. If we identify our coordinates as x1, y1 and x2, y2, I get a slope of negative 5 over 1, which would simplify to negative 5. This line falls from left to right. Let's take a look at the last one together. 3, 4, and 3, 1. Again, just go through this process of identifying your coordinates, because we'll use x1, y1, and x2, y2 in more types of kind of places in this lesson. If we do our slope then, we'll find y2 minus y1 would be 1 minus 4. In the denominator, we get 3 minus 3. To simplify then, 1 minus 4 is negative 3, but then in the denominator, we get 0. If there's a 0 in the denominator, that means the slope is undefined. So anytime you have 0 in the denominator, your slope is undefined. It doesn't mean there isn't a line. It just means that the slope is undefined. The line would then be vertical. It'd be straight up and down. And those are the 4 ways you can describe slope using the slope formula. When graphing linear equations, there should be 2 forms your equation is written in. You could have slope-intercept form, or you could have general form. When graphing, you have key information in either form to sketch the graph for your equation. If you're in slope-intercept form, the slope of the line is always the coefficient in front of x. That will tell you the rise or fall of the line, that rise over run again. The number that's written after, whether it's being added or subtracted, is the y-intercept. And that's where you would start plotting your points on your coordinate system. Now, general form might be new for some of you. If you're written in general form, you can graph the equation of the line without having to solve for y first. We're just going to now use those coefficients of a, b, and c to determine our slope and our intercept. So now our slope isn't the number in front of x. It isn't just a. Our slope is actually negative a divided by b. If you can determine that fraction, that's the slope of your line. Your y-intercept here is going to kind of be that same idea. If you can determine what c divided by b equals, that would be your start point on your graph. So we're just going to model a couple of these down below. It says sketch the graph of each linear function. In that first equation, we have y equals 2x plus 1. This is in slope-intercept form. In this form, we just need to identify those key features and we'll graph our line. The slope is positive 2. And I'm going to write it as a fraction 2 over 1. That's rise over run. Our y-intercept is the number that's written after, and that's 1. As an ordered pair, that would be 0, 1. That's where I would start graphing. On the y-axis, I would count up 1 unit and plot my point. Then use the slope and count up 2 and over 1, up 2 and over 1. In the opposite direction, I would go opposite for both parts. Instead of up 2, I'm going to go down 2 and 1 to the left. And I'm going to continue all the way through my graph. Now all we need to do is connect our dots. Go ahead and draw a line all the way through the graph with arrows on both ends. And there's your function for y, or your graph, for y equals 2x plus 1. In our next example, we have y equals 2. So notice x is missing. If x is missing, that means we're not going to cross the x-axis. So this is going to be a horizontal line. That means go to 2 on the y-axis, that's our y-intercept, and we now just draw a horizontal line straight across. How easy is that? There's the graph for your equation, y equals 2. Let's do one more. X plus y equals 4. So now this is in general form. And it would be pretty easy to get y by itself, but we wouldn't have to if we remember the formulas for slope and y-intercept. Our slope is going to be negative a over b. A is technically 1, and so is b. If we do negative a over b, our slope will just be negative 1. That's not too bad. And our y-intercept, our start point, if we do c over b, 4 over 1 is 4, so that would be 0, 4. And now we graph it just like we did our first equation. Go to 0, 4 on the y-axis. If our slope is negative 1, that means we're going to count down 1 unit and go 1 unit to the right, and keep following that pattern. I'm going to go all the way to the edge of my graph in both directions, up 1 and 1 to the left, and then draw your line from edge to edge with arrows on each side. And that's just a quick review of graphing linear functions, both in slope-intercept form and what may be new for some of you, general form. The last thing we'll do in Lesson 2.1, Day 1, is write equations of linear functions with 2 variables. We're going to use the model point-slope form. And in this form, it's y minus y1 equals m times x minus x1. This is going to be our template. The m value represents the slope of your line, so that should sound familiar. The x1, y1 is what we'll plug in, and that's a point that will be given to you in the information used to write the equation. So let's try a couple of these. It says find the slope-intercept form Hang on. We're going to back this up. As always, oh yeah, of course, simplify your answer. We know how to do that. What that means is we'll distribute the slope in and combine like terms. When you're done, your answer should be in slope-intercept. So when you're done, you'll have y equals mx plus b. All right, here we go. Find the slope-intercept form of each equation using the given information. We're really just going to plug in what we know to that template up above. M is 3, so we'll plug that in on that right-hand side. The point this line goes through is 1, negative 2. We're going to substitute those values in for x1 and y1. The plane x and the plane y will stay as x and y. We don't plug in anything for those. All right, let's see how this works. If it's y minus y1 on the left-hand side, we'll do y minus negative 2. On the right-hand side, m is 3, and then we have a parenthesis, x minus x1, so x minus 1. And then it says simplify. On that left-hand side, y minus negative 2 would become y plus 2. On the right-hand side, we're going to distribute the 3 in to both parts of the parenthesis. 3 times x minus 3 times 1. To get y by itself, we're going to move 2 over using the opposite operation. We'll subtract. Y equals 3x minus 5. And that's your equation in slope-intercept form. That's all you do. Let's try another one. M is negative 2/3, so you know there's going to be a fraction eventually. We know that to be true. And the point we want to pass through is simply 1, 1. We'll identify that as x1 and y1. To follow the template, y minus y1, y minus 1 equals m, which is negative 2/3, times x minus x1, which is also 1. To simplify, y minus 1 on the left stays as is, but on the right we're going to distribute the 2/3 in, and we're going to keep our answer in fraction form. Negative 2/3 times x, that's easy enough to keep in fraction form. If we take negative 2/3 times negative 1, the two negatives would cancel out, and we would have positive 2/3. Now to get y by itself, I'm going to add 1 to each side. And we need a common denominator. So 1, if I want to add that, I don't know why that's fuzzy, hang on. If I want to add 1 to 2/3, I'm going to give 1 a common denominator of something over 3. So that would be the same as adding 3/3. Therefore, we would get y equals negative 2/3 x plus, if we take 2/3 plus 3/3, that would just be 5/3. And that is your equation in slope-intercept form. All right, let's try one more. What's unique about this last one is that the slope is 0. So thinking about what we've talked about already in this lesson, when the slope is 0, what kind of line we'd have. This one also passes through the point 1, 1. I'll identify that coordinate as x1 and y1. Plugging it into the template up above, y minus y1 equals m times x minus x1. Y minus 1 on the left stays the same, but 0 times anything on the right, what's 0 times anything? That's just going to be 0. So now if we get y by itself, we'll add 1 to move it over, and we would just get y equals 1. And that's, remember, a horizontal line. If the slope is 0, you'll always have a horizontal line. And this is where we'll end our video. Tomorrow in our synchronous lesson, we'll complete the 3 examples at the bottom.